In this video, we're going to very briefly look at quaternary structure. Quaternary structure is if a protein is made out of multiple tertiary structures, how do these tertiary structures combine to form a big structure called the quaternary structure? And a lot of proteins, especially those over 100 kilodaltons, have multiple polypeptide chains. We call those oligomers. If the polypeptide chains are the same, we call those protomers. Now, these polypeptide chains are usually not associated by covalent bonds. Rather, you have hydrophobic interaction or hydrogen bonds, or you do sometimes have these disulfide bonds that can covalently link different subunits. Now, when you look at proteins with multiple subunits, and specifically protomers, the way that these subunits are attached together are only attached in so many ways. That is, you have symmetries, and these symmetries are seen over and over and over again. The first type of symmetry is called a cyclic symmetry. So imagine if we had a protein made out of two protomers. So one symmetry is you just take this peptide and you rotate it 180 degrees, and now they can fit together. You can do that with 3 proteins or 5 protein subunits. Now, dihedral symmetry is a little more complicated. So this green line is just showing you what type of axis you are flipping over to make this symmetry happen. So imagine that we had a protein made out of 4 protomers. Well, if they had D2 symmetry, what you do is that you just take this peptide, flip it over 180 degrees that way. So you just go over. Now this protein can also flip 180 degrees this way, flip 180 degrees this way. Then if you flip 180 degrees, you are back to where you started from. So just the way I do this is I just look at this black piece right here and just see, okay, how do I move this black piece from here to get the rotations in my mind. Here's D3 symmetry, where you have the cyclic happening as well with this also symmetry around this axis. And D4 symmetry is that you have symmetry happening where you move, okay, I'm moving 90 degrees here, 90 degrees here, 90 degrees here, 90 degrees here. That's one type of like cyclic symmetry. Then you can rotate up to here and do that same rotation, and you will come together to make this super complex of 8. And also, when we're talking about symmetry, inside of a crystal, if we're talking about protein crystals, we can have different symmetries as well. We can have a tetrahedral symmetry, a cube symmetry, or this icosahedral symmetry. The reason why you have these complicated symmetries is that amino acids only come in one chirality. So you can't have mirror images, or else the chirality of all the amino acids will flip. So nature had to devise a way to have 2 things that look the same come together, and so that's why we have these symmetries. That's it for a quaternary structure. Not much to it. I will see you in the next video.